So let's talk about interfaces. This is another programming topic that confuses a lot of people, and it's really not as difficult as it seems. Basically, in terms of Java, in terms of what we've discussed so far, an interface is just inheritance without all the baggage. It doesn't have all this weight that's associated with inheritance, all the bad things that we had. And some of the weight that's lost is the implementation details. When you create an interface is just going to specify what the contract is or what the method's signatures look like for some class that's going to implement that interface. When we use inheritance, we might have had our animal class, and our animal class might have had some methods that had some default behavior, maybe a walk or a eat or sleep. Using an interface, we might still have all those same methods. We're just not providing any default implementation. We're saying if you implement this interface, if you're going to inherit from this interface, basically, that you have to provide these implementations yourself. And so that's the basic difference here. Now, the thing that we get when we do this is suddenly we can have multiple implementations. We can implement multiple interfaces. One class, an animal or a cat, could be an animal interface. It could also be a mammal interface. It could also be a furry interface. Whatever interface that you want, it can have multiple ones of them, which you can't do in Java with inheritance because you can only inherit from one object or one class. So we get that ability, and the other ability we get is that interfaces work with polymorphism. So this gives us a way to really break apart our inheritance relationship and change it to a composition relationship where we're going to use an interface as a substitute for a base class. So an interface is just the definition of what methods need to be implemented by some class. That's the simplest way, I think, to put it in Java. And here's an example. This is our animal example again. And I name interfaces I and then the name, so I animal. This is really not a Java convention. When I program in Java, I do this anyway because I like to know what is an interface, and to me this is the most clear way. This is perhaps more of a C# convention, but you can do whatever you want. The standard way in Java to this would be to have animal and then animal impl. I find that a little bit confusing, especially the way that we use interfaces today. But with that said, this example, what we're looking at here is we have an iAnimal interface. So this is our interface. It's going to define some methods, maybe eat, sleep, walk, and then you can see, looking at the right first, we have our dog and our cat, and they both are going to implement this iAnimal interface. It's just like inheritance, except that they're not getting the methods, they're just getting the requirement to implement those methods. So if we had an eat method, for example, dog would have to implement it, cat would have to implement it. Looking at the left here, this is where we're going to get into that kind of trick where you can actually change inheritance into composition. We could have a default animal, which doesn't really model the real world. There's not like a default animal, but we could use that to put all of our methods, that all our default behavior inside there. Then we could actually have dog and cat be composed of default animals. Each one of them could contain a default animal, still implementing this animal interface, and then when they want to, for example, eat, they can just call default animal.eat and return the result of that. And if they want to do something special, they could just not call the default animal eat, and they could provide their own implementation. This gives you kind of the best of both worlds. You can both reuse the code inside this default animal class, but instead of using inheritance, you're using composition here. So let's convert our example here over to use an interface instead of inheritance. And we'll make it so that we can actually do polymorphism with interfaces instead of inheritance, and then we'll actually be able to use composition and interfaces together to avoid inheritance altogether and basically duplicate the same functionality of inheritance without all the drawbacks. So let's take this one step at a time, and the first thing that we're going to do is we're going to change our printer so that it is no longer inheriting from machine. Instead, let's create an interface called iMachine. And what we'll do here is we'll take out this extends machine and we'll put implements iMachine. And this implements keyword is how you implement an interface. Just like extend works to inherit from a class, implements is used with an interface. So I'll go ahead and let Eclipse create this interface for me. This is one of the nice things that you can do in Eclipse. It's automatically going to be able to create this because it realized that I was trying to refer to something that didn't exist. So I'm going to click Finish here, and so it's created my iMachine interface. And on my iMachine interface, let's go ahead and declare some methods that are going to exist. Now remember, you're not going to be able to declare data, you're not going to be able to declare the actual implementation of a method, but just what this interface looks like. So let's create our methods. Let's create our turn on and turn off method, because any machine should have turn on and turn off. Now, we had implemented this in machine, but for now we're just going to ignore machine and we're not going to utilize machine at all. We're going to just make it so our printer is implementing this interface instead. And so now you can see we've got a whole host of problems here because we don't have the ability to call this isOn, or to use this on isOn, or to basically use this base class since we're not using the base class anymore. In fact, what we need to do is we need to implement these methods ourselves because we're not getting the implementation from anywhere. When we inherited from machine, machine was providing us with these turn on and turn off methods. So I'll use Eclipse here again, and you can see I can just click this to add unimplemented methods. And when I do that, what it's done here is it's created a turn off method and a turn on method. In fact, we already had a turn on method, so it didn't try and recreate that because that's part of the interface. But it created a turn off method because we need to have a turn off method. So I'm actually going to move this isOn back into our class for now so that we can implement this interface properly. So I'm going to create a private variable, a boolean called isOn, and I'm going to set it in our constructor here, just like we had done before. We're going to say that this isOn equals isOn. And now when we want to call turn on, we're going to just implement this ourselves. We're going to say isOn equals true. And then for turn off, we're just going to set isOn equals to false. So now you can see we have no dependency on machine. On the machine class, we created this iMachine interface, and we're implementing this interface by having an overridden method for turn on and one for turn off. Now what this is going to allow us to do is to basically, instead of referring to our object as a machine, we can basically use this iMachine interface here, and we can set our printer equal to this iMachine interface. And we have to import this type, of course, to be able to use iMachine. So now we have an interface that is referring to our printer, and then we can call turn on that interface. So we can call any methods that exist on this interface. We don't have to know what the implementation is. That printer implements it. And so let's go ahead and run this and see what happens here. So you can see it just has the warming up print engine because it's calling the turn on method in printer when we use that interface. Now let's take this one more step further and let's go ahead and make it so that we are going to use composition in order to avoid having to repeat this logic, because we had this logic for the isOn in machine, and the problem with using an interface, a lot of people complain, is, well, I don't want to repeat this code and manage this isOn, this logic, in every single class. If we created another printer, another type of machine, we'd have to implement the machine interface and re-implement turn on and turn off. So we're going to use machine as kind of a base, but we're not going to inherit from it. And the way we're going to do that is we're going to have machine implement the iMachine interface, and then we're going to have our printer class have an instance of a machine. So just like we did with paper tray, we're going to create a machine variable called machine, and we're just going to leave this machine here, and then in our constructor we're going to construct our machine. So I'm actually going to take this isOn variable out again, and instead what we're going to do here is we're going to say that machine equals new machine, and we're going to pass the isOn here. So the machine is going to manage this. It's going to have that logic. We're going to take this logic for handling the isOn out of our actual class. And then this turn on method, we still have to implement a turn on and a turn off method. But all we have to do here is we can just say machine.turnOn. So we're going to delegate. This is called delegation because we're going to implement this interface by delegating it to our internal machine class. So for turn on, we just call machine.turnOn. For turn off, we'll just call machine.turnoff. And then this has actually helped us to figure out part of the interface that was missing that we didn't even think about here, is that this is on. We need this iMachine interface to provide a way for us to tell if the machine's on, not just to set the state of being on or off. So I'm going to go ahead and implement a method here that would allow us to check is on. So I'm going to change this instead of a variable to a method call. And then we're going to create this method. But we need to create this in our interface first, and then we want to create it in the machine because we don't want to implement this in our actual printer. So let's go into our interface here, and let's create a method that returns a boolean called isOn. And now you can see both machine and printer have an error here because they need to implement this method. So I'm going to click Add Unimplemented Methods, and for machine, it's going to have an isOn, and the way that we implement isOn is to return the value of our isOn variable. Then in printer, the way that we're going to implement isOn is we're just going to return the value of our machine's isOn. We're just going to delegate our call. So we're going to return machine.isOn. So now you can see that the same thing here when we want to check our isOn, we're just going to do machine.isOn. So now you can see we're actually not inheriting from machine, but we're able to use machine through composition. So we have the same polymorphic behavior. If we go to our main class here and run this, we're now using iMachine, and our iMachine can either hold a printer or a machine, and it's going to call the turn-on method. And so if I call this turn-on method here, you can see it's calling the code inside machine. And if we decided that we didn't want our printer to use machine's method, or we wanted to use machine's method but we wanted to do something else as well, we can just do system.out.println, for example, and we can say warming up printer. Now if we run this, you can see that it's calling our code, which is delegating to machine. So let's go over what we covered in this module. Well, the first thing that we did is we talked about the ISA and HASA relationship and how inheritance and composition are different and how they are modeled differently by the ISA relationship and the HASA relationship. Then I showed you an example of using basic inheritance in Java. We saw how we could actually create inheritance inside Java and inherit a class or inherit some data from a class. Then we went through and did the same thing for composition. I showed you how in Java you could use composition or create a class that's composed of other classes. Then we covered the difficult topic of polymorphism, and we really strove to understand exactly what polymorphism is in Java. Then we went through and we talked about how you should favor composition, and I give you my personal opinion and some advice on why composition is better to use than inheritance, especially in Java where you can't do multiple inheritance. And finally, we talked about an important concept, interfaces, which allows us to use composition and still allows us to do polymorphism. Well, that's it for inheritance and composition. I hope you learned a lot about using inheritance and composition in Java. And in our next module, we're going to get into a very interesting topic, which is generics.